Okay, so here's the relative frequency of defective sockets, okay, following testing of 1,000, then 2,000, then 4,000, 3,000, 4,000, and 5,000 sockets, okay. So you can see the relative frequency, okay, which gives us a sort of probability value, changes as more sockets are tested, okay. So how many of the first 3,000 sockets tested were defective? So after 3,000, sockets were tested, we can see there the relative frequency was this value here, okay, at 3,000 if you look. So this value here, directly in between those two. So we say the probability, okay, will be 0.05, okay. So how many, it says, it's not asking for the probability, it's saying how many of the 3,000. So what we need to do then is do 0.05 times the 3,000 to see how many exactly. You get 150. Part B then says, write down the best estimate for the probability that one socket selected at random will be defective. You must give your answer. Now, you should always go for the last one, okay? And the reason is because it's based over the most experiments, okay, the most testing, okay? So choose the last value, okay, because it's based on the most testings in this case, okay, which will give a more accurate probability. Okay, so it gives more accurate probability. Okay, the more you do of something, the more you test something, the better picture you have of it, right? So it gives you a more accurate probability. So the probabilities are getting better as you go along. And we just got to work out what this value is, because it says probability, so we need to read across. So, you know, there's no harm in drawing a line on your graph here to see where it is. Now this one's a little bit awkward because it's not quite 0.05, isn't it? It's there. So we need to figure out what that is. And between 0.04 and this value here, which is 0.05, okay, there's 5 squares, isn't there? 5 squares, and it's going up, then it's going up 4 squares, okay? So we need to split that gap into 5. Now when we split a whole into 5, you get like 0.2s, don't you? When you split a whole into 5, 0.2s, but this isn't a whole, but the same principle applies. So if you think about it, that's 0.04, so the next one would be 0.042, and then fourth one up would be 0.048, because you're going up, as I said, in 2s. So 0.042, 0.044, 0.046, 0.048. So that's what we want. And there's my answer.